What if I told you that while NASA keeps pushing back its moon landing, another space program has quietly been acing every single test, building every single piece of hardware, and has a deadline so politically important, it cannot fail? China is going to the moon by 2029. And unlike the promises we've heard before, this one is backed by national pride, political survival, and engineering that is genuinely ahead of schedule. Here are 10 facts that prove it. But before we continue, consider subscribing to the channel, liking the video, commenting down below, and sharing this with your favorite people.
Number 1.
2029 isn't just a number China picked out of thin air. It marks the 80th anniversary of the founding of the People's Republic of China, one of the most symbolically loaded dates in modern Chinese political history. Landing astronauts on the moon by that year isn't just a space mission, it's a declaration to the world and to China's own people that their nation has arrived as a superpower. Compare that to NASA's Artemis program, which has been delayed year after year, from 2024 to 2025, to now looking at 2027 at the earliest, and even that is uncertain. When a mission is tied to a political anniversary of this magnitude, the entire weight of government gets behind it. Budgets don't get cut, programs don't get shelved, it happens. That's the first reason China's moon landing is more real than most people think.
Number 2.
Here's something NASA's Apollo program taught us. You don't need one giant rocket to get to the moon, you need the right architecture. China's lunar mission uses a dual launch strategy. Instead of building a single monster rocket to carry everything at once, they split the mission into 2 launches. The Long March 10 rocket first sends up the Mango Crew spacecraft. A second Long March 10 launches the Lanyu lunar lander separately. The 2 vehicles then meet and dock in lunar orbit, and from there, the crew descends to the surface. This is elegant engineering. It spreads the risk, reduces the need for a heavier than anything ever built rocket, and means that if one component has an issue, it doesn't automatically doom the whole mission. It's the kind of solution that shows China's space architects have done their homework and learned from 60 years of space history.
Number 3.
The Long March 10 is the backbone of China's lunar ambitions, and it is no joke. Standing 90 meters tall, with a 3-stage configuration and 2 side boosters, it's capable of delivering 27 metric tons to lunar orbit. For context, that's comparable to NASA's own space launch system, the most powerful rocket currently flying.
Number 4.
Even before the Long March 10 has flown a crewed mission, China is already developing its successor. The Long March 10A is a reusable variant designed to dramatically reduce launch costs. But here's where it gets fascinating. The recovery method isn't just a SpaceX copy. Instead of propulsively landing on legs the way Falcon 9 does, China's design calls for the booster cores to be caught mid-air by wire tethers. Think about what that implies. They're not trying to imitate, they're trying to iterate. This kind of forward planning, building reusability into the roadmap from the start, tells you that China isn't thinking about a single moon landing. They're thinking about a sustainable, cost-effective lunar program. One trip to the moon is a milestone. A fleet of affordable missions is a strategy.
Number 5.
The spacecraft that will carry Chinese astronauts to the moon is called Mango, which translates roughly to dream vessel, and it's unlike anything China has flown before. Designed for deep space missions, Mango can carry up to 7 astronauts, though lunar missions will use a crew of 3. Its larger size, upgraded life support, and deep space-rated shielding put it in a different category than China's previous Shenzhou capsule, which was designed for Earth orbit. But specs alone don't build confidence. What does? Testing. Mango has already completed 2 critical safety demonstrations, a zero-altitude abort test and a max-Q abort test, both successfully. Those tests prove that if something goes catastrophically wrong during launch, the crew can escape. It's the kind of validation that turns an engineering drawing into something you'd actually trust your astronauts' lives to. And China has already checked both boxes.
Number 6.
On February 11, 2026, just days ago, China conducted a max-Q abort test for the Mango spacecraft. Max-Q is the moment during launch when aerodynamic pressure on a rocket is at its absolute peak, the point where a vehicle is most likely to break apart if something goes wrong. Testing the crew escape system at that exact moment is the gold standard of human spaceflight safety. If the abort system can pull the crew capsule away from a disintegrating rocket at max Q, it can handle virtually anything. China's system worked? That's not a small thing. That's a critical human rating milestone, the kind that puts a mission on the path to being certified safe for crew. And it happened successfully, on schedule, in early 2026. Mark that one off the list.
Number 7.
The Lanyu, whose name means "we can clasp the moon," is the vehicle that will actually set Chinese astronauts on the lunar surface. And it has already been through some of the most grueling tests a lander can face, short of going to the moon itself. In 2025, Lanyu underwent landing and takeoff tests on Earth under simulated lunar conditions, meaning reduced gravity simulations, actual descent and ascent engine firings, landing leg deployment, and control system verification. Every major subsystem that has to work flawlessly on the lunar surface was put through its paces here on Earth first. This addresses what has historically been one of the hardest technical risks in any lunar mission, actually getting down to the surface and back up again. China didn't wait until 2028 to start testing this. They started testing it in 2025. That is what a program that's serious about its deadline looks like.
Number 8.
Getting to the moon is hard enough. Staying in contact with it and navigating precisely on it is another challenge entirely. China is already solving that problem. They also launched Tiandu 1 and 2, a pair of experimental navigation satellites designed to test a lunar positioning system. Think of it as the early construction of a GPS network for the moon. Before the first Chinese astronaut sets foot on the lunar surface, China is making sure they'll always know exactly where they are. And that mission control back on Earth will always be able to talk to them. That's infrastructure. That's long-term thinking.
Number 9.
You can have the best rocket, the best lander, the best navigation system in the solar system, but if your astronaut can't step outside, none of it matters. In September 2024, China publicly unveiled its new lunar EVA suit, and this wasn't a mock-up or a design concept. This was a functional, demonstrated suit, shown performing a full range of motion on a real human being.
And number 10.
Here's the fact that should make every space enthusiast sit up straight. As of early 2026, NASA has not yet completed a max Q abort test for its Artemis crew systems. China just did it. NASA hasn't. To be clear, NASA is still working on Artemis. The SLS rocket has flown. The Orion capsule has flown. But in the specific, critical area of validating that a crew can escape safely at the most dangerous point of launch, China has now crossed the finish line of a test that NASA has not. 10 facts. 1 conclusion. The next humans to walk on the moon might not be American. That's not pessimism. That's a wake-up call. China has a deadline backed by political will, a rocket ready to fly, a crew capsule that's passed its hardest safety test, a lander that's already touched down in simulation, a spacesuit that's already been worn, and a communication network already in lunar orbit. They are not almost ready. They are getting ready. And 2029 is closer than it sounds. If this surprised you, share this video. Because most people still think the space race ended in 1969. It didn't. It just took a 50-year intermission. Subscribe if you want to follow how this unfolds, because between now and 2029, every test, every launch, and every milestone is going to matter. And we'll be covering all of it. The moon is waiting. The question is, who gets there first?